Here we have to integrate 10x raised to 5, which is in the form of 10x raised to n. So first of all, let's split this 10x raised to 4. We have to split 10 square x into 10 cube x dot dx. Now this 10 cube x will be as it is. We have to convert 10 square x in terms of sec square x minus 1. So here we complete our first step. Now let's move to the second step. Open the bracket. 10 cube x into sec square x will be 10 cube x into sec square x minus 10 cube x. Okay. Now we have to repeat the first step for this 10 cube x, or we can say rest of the terms will be as it is. 10 cube x will be split into 10 square x and remaining power is 1. Still your first term is as it is. Let's simplify the second step. 10x, and instead of 10 square x we have to write down sec square x minus 1 dot dx. Again first term as it is and open the bracket. 10x into sec square x, 10x into sec square x, minus minus become plus 10x dot dx. Now as you can see, we have sec square x in first and second term, but in third term we don't have any term of sec square x. So let's split the integration. Let's say your first two terms is one integration, so we can take sec square x common from them. So we'll get 10 cube x minus 10x and sec square x dot dx will be common, plus integration of 10x dot dx. So let's integrate them separately. Let's say your first integration is I1, which is integration of these terms. And to integrate I1, we have to assume 10x is equal to t. So we will get sec square x dot dx is equal to dt. So our I1 will be modified as t raised to 3 minus t, and this sec square x dx will become your dt. So we are ready to integrate. Integration of t cube will be t raised to 4 by 4 minus integration of t will be t square by 2 plus c1. And to get the final answer, just substitute the value of t, which is 10x. So here we'll get 10x raised to 4 by 4 minus 10x the whole square by 2 plus c1. Now it's time to integrate our I2, which is integration of 10x log mod sec x plus c2. So our original question I, which is equal to I1 plus I2, will be the value of I1, which is 10x raised to 4 minus 10 square x by 2, plus the value of I2, which is log mod sec x plus c, where c is c1 plus c2. So tada! This is your final answer. Here we have to integrate 10x raised to 4, which is in the form of 10x raised to n. So first of all, we have to separate 10 square x. So let's take 10 square x, separate. Remaining power is also 10 square x. Now this 10 square x will be as it is. Instead of 10 square x, we have to write down sec square x minus 1. So it's open the bracket. Tan square x into sec square x will be tan square x into sec square x minus tan square x into 1 will be tan square x. Now, this first term will be as it is. We have to repeat the first step, or we can say instead of tan square x, we have to write down sec square x minus 1. So here we get the terms of sec square x in first two terms and 1 will be separated. So let's take sec square x common from the first two terms. So we'll get tan square x minus 1 and sec square x common plus integration of the last term, which is 1. So first integration is called I1 and second one, let's call it I2. So let's integrate one by one. First of all, let's try to get I1. Now as we plan, let's assume tan x is equal to t. So we'll get sec square x dot dx as a dt. So we are ready to modify our I1 as a t square minus 1 and this sec square x dx will become your dt. So integration of t square will be t cubed by 3 minus integration of 1 will be t plus c. Just substitute the value of t, which is tan x whole cube by 3 minus tan x plus c1. Okay. Now we have to integrate I2, which is simple integration of 1. So integration of 1 with respect to x will be x plus c2. So here we can get our I, which is I1 plus I2. So let's get our I1 plus where I2 plus C, where C is C1 plus C2. So tada! This is your final answer. Here we have to integrate tan 2x raised to 3 into sec 2x. Let's split this tan 2x cube as tan 2x the whole square into tan 2x, and this sec 2x will be as it is. So actually we said the differentiation of sec 2x. So we should convert this tan square 2x in terms of sec square 2x. So let's write down sec square 2x minus 1 instead of this tan 2x, and tan 2x into sec 2x dot dx will be as it is. So we are ready to assume sec 2x as a t. So we will get differentiation of sec 2x as a tan 2x into sec 2x dot 2 dx is equal to dt. We have tan 2x into sec 2x within the multiplication of dx. So let's take 2 on the right side. So we'll get dt by 2. So we are ready to modify our integration. This sec square 2x minus 1 will become t square minus 1, and sec 2x dot dx will be your dt by 2. So 1 by 2 is outside. Integration of t square is t cube by 3 minus integration of 1 will be t plus c. Just substitute the value. So you'll get 1 by 6 sec 2x the whole cube minus sec 2x by 2 plus c is your final answer. Ta-da! Here we have to integrate 1 minus cos x upon 1 plus cos x. We have 1 plus cos x in denominator. So let's multiply and divide its conjugate. So we'll get 1 minus cos x upon 1 minus cos x. So In numerator, we have 1 minus cos x the whole square, or we can say 1 minus 2 cos x plus cos square x. And in denominator, we have a plus b into a minus b. So it becomes a square minus b square, or we can say 1 minus cos square x, or we can say it is sine square x. So let's give individual denominator. 1 upon sine square x minus 2 cos x upon sine square x, or we can say sine x into sine x, plus cos square x upon sine square x. So here our first term will be 1 upon sine square x, or we can say cos x square x, minus in second term 2 will be as it is, cos x upon sine x will become cot x, and rest of the 1 upon sine x will become cosine x, plus cos square x upon sine square x will become cot square x. Now let's go to simplify cot square x for integration. So we can say your first two term will be as it is, and instead of cot square x we can write down cos x square x minus 1 cos square x plus cos square x combinedly become 2 times cos square x. So we are ready for integration. The first term 2 will be as it is, integration of cos x square x is minus cot x, minus 2 will be as it is, integration of cot x into cosec x will be cosec x, minus integration of 1 will be x plus c is your final answer. We can solve the same question in different way. Our question is integration of 1 minus cos x upon 1 plus cos x, and we can convert 1 minus cos x upon 1 plus cos x as a tan square x by 2, and to integrate tan square theta we have to convert into sec square theta, or we can say sec square x by 2 minus 1. So we are ready to integrate. Integration of sec square x by 2 is simply tan x by 2 upon coefficient of x, or we can say 1 by 2, minus integration of 1 will be x plus c is the final answer. Ta-da! Here we have to integrate cos x upon 1 plus cos x. Here in denominator we have 1 plus cos x. So let's multiply and divide its conjugate, which is 1 minus cos x. So in numerator we will get cos x ones are cos x minus cos x into cos x, cos square x. And in denominator we will get 1 minus cos square x, which is sine square x. So let's give individual denominator. In first term we will get cos x upon sine square x, or we can say sine x into sine x, minus in second term we will get cos square x upon sine square x. If we further simplify as this cos x upon sine x will become cot x, and remaining 1 upon sine x will become cosec x, minus this cos square x minus sine square x will become cot square x. Now for integration we have to simplify this cot square x. So we can say our first term is as it is, and instead of cot square x we can write down cos x square x minus 1, with this minus minus will become plus. So we are ready to integrate. अब बोलो क्या होगा? Integration of cot x into cosec x will become minus cosec x minus integration of cos square x will be cot x plus integration of 1 will be x plus c is your final answer. Ta-da! Here we have to integrate sin square x upon 1 plus cos x. So let's multiply and divide by the conjugate of 1 plus cos x, which is 1 minus cos x. So in numerator, we will get sin square x into 1 minus cos x. And in denominator, we will get 1 minus cos square x, which is sin square x. So here, sin square x will cancel out. We just have to integrate 1 minus cos x. So integration of 1 will be x minus integration of cos x will be sin x plus c is your final answer. Ta-da! Here we have to integrate cos 2x plus 2 sin square x upon cos square x. Here, two terms have angle x and this cos have double the angle. So for simplification, we have to convert this cos 2x in terms of x. So it is preferable that we have to use the second formula of cos double the angle. So let's write down 1 minus 2 sin square x instead of cos 2x plus 2 sin square x upon cos square x will be as it is. So now we have same angle in all trigonometry terms. Simplify. This 2 sin square x will cancel out. We just have to integrate 1 upon cos square x, which is basically integration of sec square x. Integration of tan square x is tan x plus c is your final answer. Ta-da! Here we have integration of cos 2x upon cos x plus sin x the whole square. Let's convert this cos 2x in terms of cos square x minus sin square x upon cos x plus sin x. The whole square will be as it is. Now we can simplify our numerator as cos x plus sin x into cos x minus sin x upon cos x plus sin x the whole square still remain as it is. So here 1 power of cos x plus sin x will be cancelled out and we will get cos x minus sin x upon cos x plus sin x. So we get the differentiation of denominator into the numerator. So let's assume cos x plus sin x as a t. So when we differentiate it, we will get minus sin x plus cos x dot dx is equal to dt. So we can modify our integration as this cos x minus sin x dot dx will become dt and 1 upon cos x plus sin x will become 1 upon t. So integration of 1 upon t is simply log mod t plus c. And to get the final answer, just substitute the value of t, which is cos x plus sin x. So log cos x plus sin x plus c is a final answer. Ta-da! Here we have to integrate cos 2x minus cos 2 alpha upon cos x minus cos alpha. So in numerator, we need to get in terms of cos x. So let's use first formula of cos 2a. So this cos 2x will become 2 cos square half the angle minus 1 minus this cos 2 alpha will become 2 cos square alpha minus 1 and your denominator still remain as it is. Now Let's simplify our numerator. This 1 will cancel out. We will get 2 cos square x minus 2 cos square alpha upon cos x minus cos alpha. Now for further simplification, we can take 2 common and cos square x minus cos square alpha can be converted into cos x minus cos alpha into cos x plus cos alpha upon your cos x minus cos alpha still remain as it is. So here cos x minus cos alpha will cancel out. We just have to integrate cos x plus cos alpha. So we are ready to integrate. Integration of cos x is sin x plus integration of cos alpha will be x cos alpha plus c. Ta-da! Here we have to integrate sine inverse of cos x. Actually, we have sine inverse function. So we need to get sine function within the bracket. So let's convert cos x in terms of sine by taking pi by 2 minus x. So sine inverse and sine are inverse function of each other. So here we'll get pi by 2 minus x. So we just have to integrate pi by 2, which is purely constant term. So it will be pi by 2x minus integration of x will be x square by 2 plus c. Is your final answer. Ta-da!